This is the model answer video for the multiple choice. You did this with the component 3 at key assessment 1. Right, multiple choice. You're not going to get a multiple choice, however this is a great way of doing revising. What I'm going to do is run through these, and if there's anything blatantly wrong I'm going to cover it in red. If it's good, then good is green. So first of all, we've got a circle, and we are working the area out. So that's pi r squared. So the question is, what is r? So the radius is from there to there. That's the radius, and we can't use this eyepiece scale, but here we have the stage scale, and 0.1 millimeters, 0.1 millimeters. That's the information that we know. If that was across the middle of the radius, what would we have? We'd have 0.1 plus an extra bit there, so 0.125 millimeters. So radius equals 0.125 millimeters, which is there to kind of there, 0.125. So if you put the 250 micrometers, then that is the diameter, whereas 125 is our radius. So pi r squared. These other ones are just red herrings, really. Structure found in both animal and plant cells. Well, even if you can't remember which way around it is, one of them hasn't got centrioles, so that's wrong. And so 2, 3 and 4, you could possibly argue for 4, possibly, but is there an answer for 2, 3 and 4? 2, 3 and 4. There is. Okay, yeah. So if we're happy that if we get sort of temporary vacuoles sometimes in animal cells, 2, 3 and 4, that's our C there. So C there, sorry, no, we got C there. Okay. Question 3, a little bit tricky. And molecular structure of starch suited to its function. So molecular structure suited to its function. Amylose branched, amylopectin coiled, is that the right around? Give a compact molecule for anyway, this is completely wrong. So even if you can't remember which way around those two are, transport's wrong. Break down many hydrolysis reactions. So breaking that down, yeah, that's true, but release stored energy. Well, do hydrolysis reactions release stored energy? No, because that is respiration that you need for that. So the hydrolysis will actually need energy. The formation of amylose and amylopectin, many condensation reactions release the energy. Well, it's even wronger than B, because it's condensation reactions. They build things, not break things down. And again, that wouldn't help you release stored energy. And so it must be D. Hopefully what D says is actually true. The final complex is insoluble, yes. We're happy there. Does not affect the osmotic properties, yep. So we've got D there. We have got beta glucose, question mark. Well, what's alpha glucose? Let's draw alpha glucose. So same sort of shape, oxygen, and with the OHs it's down, down, up, down, and there's one up there I'm just not going to worry about just a moment. So, and then with beta glucose we are swapping round the OH group on carbon 1. So we're looking for one that is down on the left, up on the right. So down on the left, up on the right, down on the left, oops, that's down, and then that's not down on the left, that's not down on the left. So here we are, down on the left, up on the right, so it's A. How many fatty acid residues are present in a phospholipid molecule? Well, here's a phospholipid. It's a residue of glycerol, phosphate head, and then we've got 2 fatty acid residue tails. And so how many have we got? 2. Because we are thinking about those 2 there. Question 6. A frozen lake warms after a cold winter. Mineral nutrients are brought to the surface. So if something's moving up or down, it's got to be something to do with density. That's the only reason why water or air would rise or sink. So it's got to be something to do with density. So that statement there, its greatest density is at 4 degrees C. It has a high specific heat capacity. That is true, but is it relevant? Would this process still occur even if it didn't have quite so high specific heat capacity? It probably would. So whilst it's true, is it relevant to this question? Which contribute to this process? It's a solvent. Well, we're talking about mineral nutrients. So, for example, dissolved organic nitrogen, like nitrates and things like that. So, solvent is going to be relevant, and its molecules form hydrogen bonds. Also true. But is that relevant in contributing to this process? You can argue that both of these contribute in some way to it, but if we're going to argue for all of them, we're looking for 1, 2, 3 and 4, so we can't do that. So the only ones that are really going to contribute to that process are 1 and 3, which must be A. Question 7. Which feature distinguishes starch from glycogen? Starch contains alpha glucose, so that is true. But it's also true for glycogen, so it doesn't distinguish. Starch contains 1,6 glycosidic bonds. Well, does it? Has it got any branches? Yes. But glycogen also has branches. So part of the structure of starch is kind of branched. Part of the structure of glycogen is branched. So we can't say that. Starch has an unbranched component. So in addition to so that's glycogen, that's starch. We've also got a coiled component of amylose component. So that's true. Starch is a polysaccharide. Well, glycogen is a polysaccharide as well. So the only one that distinguishes them is C. And some sneaky component 3 questions. So we've got an ECG of a heartbeat, single heartbeat, which let us identify the flow of current through the atria and the recovery of the ventricle walls. Even if you've never seen one of these before, you'd know the order. So the current through the atria is the initial thing that happens, and recovery of the ventricle walls. So that's going to be the last thing that happens. So, and in the middle somewhere, we're going to have contraction of the the ventricle walls. So the big contraction is the big peak here, So that's the ventricular systole, and this first thing that happens is our atrial systole, and then the last thing that happens is our recovery of the ventricles. So we're looking for something that starts off with P first. So definitely not those two. They start off with Q, and then we're going P and R, or P and T. Well, we know that R is the ventricular systole. It's a big spike, so it's not going to be A, because that's going to be wrong. And so our answer is B. Straightforward. Systolic blood pressure. Well, think about if they take your blood pressure, where do they take your blood pressure? Well, they wrap something around your arm, and it kind of contracts on your arm and detects the pressure there. So those are not ventricles or anything like that in your arm. Those are normal blood vessels. So we can get rid of anything that says ventricle, and that says ventricle. Okay, and then we're left with two answers here. Blood pressure in the arteries when it's relaxing. Well, systolic is our contraction. Diastole is the relaxing, so we can get rid of that because that would be diastole. And so we're left with, even before we've read it, we're left with the right answer. And then does it tally up? Maximum blood pressure in the arteries. So maximum systolic, arteries. Well, that's what you're actually measuring when you measure blood pressure. And question 10. Well, a little bit of debate about this. What can we say about some of these answers? So we've got heart valve. So semilunar valve is too narrow, so blood can't get through the semilunar valve. And we've got the tendons of the heart valves are weakened by blood being forced back through the bicuspid left valve into the left. That's possible. I'm not quite sure about that one. Cardiac muscle of the left ventricle wall is thinned by blood leaking out of the left ventricle. So blood leaks out due to a narrow semilunar. Well, it doesn't say it doesn't open and close properly. It's narrow. So I don't think blood would leak out. And would it leak out during diastole when it's relaxing? Well, most of the blood would be in the arteries anyway. So B's rubbish. There is less cardiac muscle in the left ventricle and reduced diastolic blood pressure caused by smaller blood entering. Well, blood entering the left atrium, well, that's not been affected, is it? So, no. And the wall of the left ventricle thickens, leading to an enlarged heart, an inability to relax and fill completely. Well, you can imagine this. So the wall of the left ventricle thickening because it's having to push blood through a narrow opening. That might lead to an enlarged heart, inability to relax and fill completely. Well, it would if the muscles thickened. So that sounds sensible. A is not quite sure about, but D sounds more sensible. So sometimes you've got to guess these things, and so we're going for D, which is indeed the right answer.